Hello everyone, welcome to FOSDEM Day 2, and our first main track of the day is Langdon White, Rethinking Linux Distributions.
Hi everyone, I would just like to point out it's not only early for you, it's early for me, so I apologize in advance if I seem a little sleepy. As you said, my name is Langdon and this is Rethinking Linux Distributions. So this is me. I used to be an evangelist for enterprise Linux for Red Hat. Now I'm a platform architect for the developer experience part of the platform. I assume everyone can hear me because I can hear myself echo. Let me know, raise your hand, yell at me or something if you can't. Currently I'm working on a kind of what we call the objectives in Fedora, which is called modularity. And most of this talk is about that, so I'm not going to explain what that is. This is my son Thomas. He plays a lot of soccer and basketball, and he does a lot of homework, and oddly uses Instagram to talk to all his friends, which I find very odd, but then again, I'm old, so maybe that's why. So, moving on. To start off, distributions are awesome. You know, they just might be getting a little old, you know, and they fit together really, really nicely. But there's basically some issues, and they've been great for the last 20 years, right? And let's say the first 5 or 10 years of them, they really, really fit the need, and really trying to let the owner of the kind of the machine that the distribution was running on be in charge of it, right? So being less dependent on the vendors. And taking some of that control away from vendors, which they had before. And the problem with that was, and sorry, just to explain, when I say vendor, I mean typical proprietary software company. I also mean open source projects. So basically, whoever it is that's writing the software that you want to run as an application on your operating system. So I don't necessarily mean a company, just, it's kind of a good word for that class of applications. So what happened was, right, you couldn't trust them to deliver kind of timely updates, particularly for security vulnerabilities. So you wanted, as an operator of that machine, to be able to update it independently. And the distributions, in my mind, right, one of the big values they brought to the table was the ability to disconnect those two things. However, as we've moved on, what we've started to notice is that the operating systems, the frameworks that applications use, and the applications themselves really have often very different life cycles. They not only have different life cycles from themselves, right? So, you might have an operating system that wants to be around for 10 years or longer, like RHEL, right? Or you might have one that wants to be around for like a year or 13 months, technically, like Fedora. And then kind of everywhere in between, right? Then you also have kind of the framework. So you might have something like Rails, right? Or you have something like Flask, right? And they have very different life cycles as well. And then you have the applications themselves. If you take something like, a marketing site, right, that is going to be promoting a movie, it's going to have a lifespan of, call it 3 months, right? Whereas you take an ERP, and it's going to be 10 years before you want to spend the next several $1 million to reinvest in it. So that's really started to show up and started to really be a problem. Actually, it's kind of funny. I saw a talk in the distributions room yesterday. It's called, and for some reason my notes aren't showing up, so apologies, but it was distributions from the perspective of a packager, and it was talking about MariaDB and how much of a different life cycle MariaDB has than something like Fedora, and how much of a problem that is. So I thought it was funny that that talk was actually very much about it, and I highly recommend watching it on the video. The other thing that's changed is how we build software has also seriously changed. In the kind of early 90s, a lot of developers basically did everything, right? I know when I was starting out, again, I reiterate, I'm kind of old, I had to be able to replace a hard drive, right? Because there would be a server that I needed to replace the hard drive on so my application would run. Now that's kind of not something you really do anymore. I have a terrible example of somebody who used to work with me that he wasn't entirely sure where the files were on disk that were part of his Java application, right? He always used Eclipse, and it just was there, and he didn't really know exactly where it was. So he went into that classic bug of Java on Windows, which if the file path was too long, it would just fail. And he didn't really know how to fix it because he didn't really know where the files were, which for me was just astronomically bizarre. Probably for a lot of you too, but it kind of proves the point, I think, a little bit that developers are fairly, application developers are fairly far away from actually understanding the operating system that they're running on. Then we started to striate out all those different jobs, right? And then we had SQL administrator, we had like DBAs, we had SQL developers, we have QE people, we have UX designers, we have back-end developers, we have front-end developers, so we have all these different kinds of subfields within software application implementation, right? I hesitate to call it computer science. And what we saw was, as a reaction to that now we had all these split brains, right? All these people, one person didn't know everything anymore. And so we started to suffer from the lack of communication between those people. And then we said, hey, maybe we should have them talk to each other. Wouldn't that be interesting? And so we kind of saw the advent of Agile, right? Which said, let's actually bring the people who are providing the requirements into the process. And then more recently, we've had DevOps, which is let's have the people who are kind of running the applications, bring them into the process. There's a lot of other things to both of those, but kind of for my purposes here, that's the only part I'm going to cover. The other thing that's been big, right, is data science is another huge thing, right? Is now we really need to kind of have massive amounts of data compared to any applications we did prior. So all these things are changing. The other thing that's been happening in the past couple of years, this is an interesting book by Steve O'Grady, that the kind of pendulum of power has switched from, in the kind of early 2000s, from the kind of administrators being the ones who were in charge of what actually got released. Risks as well. So, this marketing site, because it doesn't actually have any real data per se, right? It's not collecting user information. It's just, essentially a read-only site, brochureware kind of thing. Maybe it doesn't need to have the same quality of components, quality of dependencies that this ERP that is, basically running our business does. It also, because of that lifecycle thing, might be able to use a much more bleeding edge version of something because we don't have to wait for its maturity to ensure that it's going to have a life cycle of 10 years for the dependencies as well. And this is what kind of is the crux of the problem, I think, is that updating those dependencies can have unintended consequences, right? And this is my representation of bug-for-bug compatibility. I hope you like it. One of the things that happens with software developers, right, is that we've got a deadline, we want to get the application out the door, and we know that this framework has a bug in it, so we write a workaround, right? And we put it directly into the application. If the admin comes in and updates that dependency and fixes that workaround, or fixes the bug that my workaround was going around, that may actually introduce a brand new security problem, right? It may introduce a brand new bug that I have no way as an application developer of knowing about, testing for, writing for, anything, because I don't have the control over the application itself. Personally, some of the excitement around things like containerization and unikernels and things like that, particularly from application developers, they're essentially taking back control over their dependency tree as well as their applications themselves. And that's part of what's so appealing, right? You know, it worked on my machine becomes true with all the problems that goes with, right? So in Fedora land, a couple of years ago now, Matthew Miller, and he thanks a lot of people in kind of this presentation, came up with this kind of idea of the rings proposal, or Fedora.next, where the idea was to start to try to recognize some of these problems and to try to redesign the distribution in such a way that there's kind of a central core that has the kind of the hard and mature and potentially long-running pieces at the same quality that we would consider important for a typical distribution these days, and then kind of have the next level out be something like the frameworks or the things that enable other things. So, your containerization technology might go here, your virtualization technology might go here. Things like Flask may or may not go here. It kind of depends on the individual example. And then after that, we start to talk about the applications themselves. And it's represented here as 3 rings, but we'll talk a little bit more about, really that's potentially a lot more than that, right? So we took kind of the first step towards this solution in what's called the Fedora editions. And the idea here is that the operating system or the distribution that we were delivering depended on the use case of the end user. So as a result, we wanted to give kind of the availability of content, and when I say content here, I mean kind of like software binaries, I mean documentation, I mean everything, right? To the different use cases and let them choose which ones were important to the use case they wanted. So for example, the workstation edition, comes with some sort of user experience that is, graphical, right? A desktop environment. The server one is, doesn't, right? It's basically just command line, but it might have some other features that don't make a lot of sense in the desktop version. So for example, and I'll talk about this a little bit later, the ability to easily install, something like a DNS server, right? Which you may not need to be able to do quickly and easily on your workstation. All the content is still there for the workstation. It's just that kind of what you're given by default, what you're given access to, and the choices you can make are kind of all geared to that use case to begin with. So we also have the cloud version, which kind of also starts with kind of all those. It starts without a firewall, right? Because a lot of times in cloud distributions, you don't really need a firewall. Related to the cloud one is the Atomic distribution, which, if you're familiar with our stuff at all, Atomic is kind of an instance of the operating system that is non-changeable, right? So yum install doesn't work. You have to, basically the way it's meant for kind of that full-on cattle model where you have to change the server that's actually feeding the images to the individual operating VMs or machines. Sorry. After that, we started to kind of go all the way to the outside and start to make kind of the outermost ring, whatever number ring that is, but the farthest away, and created this thing called Copper, which is cool other repositories. I really wish it was cool other repository, because it would make lots and lots of my grammar Nazi problems go away. But this is basically a facility for any person to create, a set of RPMs and their dependencies and all that stuff, and make them available to any users who choose to use it. DNF, which is replacing yum in Fedora, actually has a plugin that will allow you to search the Copper repos and enable Copper repos so that you can kind of say, oh, I know Bob down the street, has been putting up this RPM for the latest version of LibreOffice. Like Fedora 22, for example, shipped with LibreOffice 4, I believe, and somebody had put up LibreOffice 5 in a Copper repo so that I could pull it down before 23 came out, which was shipping it for real. Obviously, it was potentially a little buggy. Potentially it was beta quality, but I was okay with that. It was just, it's just the thing I run my presentations with, so, whatever. And so the idea is basically to try to open up that far reach of applications so that you don't have to have the same quality that things that normally would go into the distribution are available. And the idea was that things would hopefully mature over time, right? And the idea being that, they're in the outermost ring to start with, but over time they kind of get closer and closer to the center so that, kind of with increasing maturity. After that, there was a proposal, and this, last I knew, has not actually been ratified yet, of let's talk about it as kind of the next ring in from the way outside. And this is the idea is that there would be a selection committee that would say, this copper, and that copper over there are mature enough to actually be promoted to being a real repo of some kind. And this was called Playground. And you could enable it, but it would start to have stronger rules around the maturity of the software in it, its ability to install multiple things without being conflicting, et cetera, et cetera. So that was kind of the next piece in progress. After that, or around the same time, I can't remember exactly, was the ALIF proposal. And this was actually a proposal to define all the rings. So even though there's 5, right, there's 6 ALIFs here. And it comes from the math term rather than the Hebrew term, but the math term of like ALIF 0 is basically the set of integers, right, and ALIF 1 is the set of ordinals. But that kind of idea is that, okay, we have a set of applications, and they have individual kind of packaging guidelines, individual packaging rules, depending on which set it wants to be a part of. 0 being the strictest, right, and 5 being the least strict was the idea there. All right. Then we started to really run into the problems. And this is basically that the rings metaphor starts to fall down. And the reason is some of the reasons that I gave earlier, which is that it's not concentric rings. There's multiple orthogonal metrics by which you want to compare or decide upon your software. And they're just not the same, right? And so you also have even weirder stuff where things like, what about build dependencies, right? If a build dependency is required to build ring 0, does it need to be of ring 0 quality? Well, not necessarily, right? It just needs to be able to produce ring 0 quality stuff, right? But it doesn't necessarily need to be packaged or shipped or have the same life cycle or any of the other things, right? So I should be able to build, a containerization tech with GCC. GCC only has, kind of like a year before you want to upgrade GCC. So, but the thing it built, you may want to have for 10 years, right? So it's weird. And then it gets even weirder when you start talking about things like unit tests, right? What about the testing for it? Do those things belong in ring 0? Well, that gets weird, or docs, right? So it starts getting weirder and weirder, and you start to recognize that this whole thing just starts to kind of fall down. I did all kinds of weird things with bubbles and with Venn diagrams and stuff, trying to make a picture that made this work, and I couldn't figure out how to do it. The other thing is that it's still very much, everything basically I've been talking about so far still involves RPMs, right? And at the end of the day, application developers don't want to learn another language that they use incredibly infrequently. Okay, it could be RPM, it could be Deb, it could be whatever. They don't even really even a Ruby guy, right, doesn't really like doing anything related to gems. but he does it much more regularly, right? When you talk about things like distro packaging languages, you know, if you're lucky, you're doing it every 3 months, maybe every 6 months. So that means you're basically learning the entire thing from scratch every time. So the burden is just way high, right? This is my old thing about, like, you know, trying to use HTTPD, right? Using Apache and virtual hosts. It's like, I do this once every 6 months, right? Every year. I can't remember the syntax for it, right? And it's not like it's like anything else in the entire world. So I have to relearn it every time. That's a huge pain. And personally, like, that's the huge appeal of something like a PaaS, right? Is that I don't have to learn the intricacies of administration, like system administration kind of side of the house every 6 months, which is no fun. All right, so now what? So this is where we've started to go, is this kind of concept of modularity. And there's a couple more slides too, so this isn't the only thing. But one of the things is, can we start to think about providing components to software applications at maybe a higher level than typical packages, and start to treat them at a higher level as a particular package. Actually, one thing I didn't really mention as well is open source 1, right? So now distributions are in huge amounts of trouble, right? This whole open source thing has just been a terrible mess because, oh my God, now everyone is doing it. So we have an incredible proliferation of packages that need to be distributed, need to be updated, need to be tested. And, you know, it's great, right? Except for the horribleness of now, I don't even know what the numbers are, but it's ungodly. It's like, you know, 100,000 packages, right? So trying to maintain those things at those microscopic levels is also incredibly difficult, right? So can we start to think about these things more like as modules is what we're calling them. It's kind of, there's not really a great word for it. But this is the idea, is that can we have the concept of a web server that potentially has, you know, an API, right? That is what will be met by that web server, but not necessarily guarantee that it will always work the same internally. So the packages inside said web server may change, right? But that the outside API is still going to remain the same. And as far as application developers are concerned, normally speaking, there's always exceptions, but normally speaking, that's a good thing, right? That's fine, you know, because I don't really care if mod SSL, you know, version 3 versus version 37 is on the inside, right? As long as it does SSL stuff right, you know, as an application developer. So this is kind of the idea of the modules. Another point is, the other problem we've been having, right, is like, what is core? What is the center? What's that ring 0 or even ring 1? Because the distribution is thought of as a distribution, its cyclic dependency structure is insane, right? Like, everything is connected to everything all over the place. So part of the effort is to also try to break down what is actually the operating system part, right? And then let's make it even more fun and start talking about containers, which has an operating system, except it doesn't have a kernel, which kind of also breaks that argument. So that also becomes complicated, right? And has been something we've been working on for a while. There's also kind of related, but for slightly different reasons, is kind of a minimization effort, right? Is that you want your containers to start off as small as possible, right? You want your VMs to start off as small as possible and have the bare necessities that you need to be able to run your application. You know, a lot of people talk about it as for attack vectors. Some people talk about it because they, you know, need to ship, you know, 50,000 of those throughout their data center. But the point being is that minimization is important from kind of multiple facets, not just because you want to simplify. And then the other one is, how do we get developers connected to this? Well, they already are using all kinds of crazy packaging formats that they use certainly more regularly, right, than things like RPM or Dev or whatever. And I guess the argument here is, what if we let them use them, right? What if we found a way to, the problem with most of the problem is, first of all, that they're all completely different, of varying levels of quality as far as package, people who write packaging systems are concerned. And most importantly is that they don't deliver things like metadata, which is my little card catalog graphic there, very nicely, right? So, or at least in a similar way. So I can't write a DNF plugin that in a generic way is able to consume the metadata from all these different things without a whole lot of work, right? As well as I want the developer to be able to actually just be able to use, Ruby Gem, right? Or NPM or whatever. I don't want him to have to deal with, making sure that his, that the individual package that he pulls down has got the right name, or he knows how to install it and get it from things like DNF. I just want him to be able to do the things the way he does them, as a developer, right? And just kind of go on their merry way. And then kind of in a related way, right, I want to give him a big bag to put that stuff in so that he can ship it to his customers, whatever that means, right? It could be an open source project, could be a proprietary product, could be a whatever. The problem's still the same, right? Is that you want to give them a bag to put the stuff in, that then the user can get said bag, right, and then run the application without him having to go through all kinds of machinations. So, sorry. So this is kind of where we're going for the next phase of this work, is to try to bring all these things together. Can we provide developers a way to directly use the content that they're used to in a way that they're used to, then also provide kind of next level up components so that they can, so if you're a Drupal developer, right, you can just kind of grab a web server and grab a database server and then put Drupal on top, and you can rely on your Drupal still running even as the database and web server are getting updated, right? Can we also try to figure out a way to give them deliverables, right? Or sorry, a way to deliver those things. And maybe that's containers, right? Maybe it's something like meta packages, except generated RPM specs. Who knows? But the point is that we need to be able to give them a way to distribute those applications. And then finally, we need users, and in this case, users actually means both developers and end users, to be able to look at that matrix of various, kind of like I was saying, that orthogonal metrics around an individual component and decide when they want to choose it, if it's right for the scenario that they want. And the reason actually I showed, and this is coming as an American, I don't actually know what they do for this anywhere else in the world because it's not something that comes up in conversation for me. But one of the things that they do when you want to do your retirement planning in the US is they ask you a series of questions, and basically they come up with this like pie chart. And I kind of showed one from, this is Sun Life. Where'd it go? They kind of come up with this pie chart, and then you kind of say, okay, this is my pie chart, and then there's all these mutual funds, right, which are collections of stocks, and you kind of match your pie chart to the other pie charts, right? And basically that's how you do your risk assessment, right, is you kind of say, okay, these are, I'm going to retire in 50 years, and I have 37 kids, and, et cetera. And that's how you get your little pie chart, and then, you're supposed to match that against the funds you should invest in. We need to be able to provide our end users, like I said, developers and users both, and say, hey, you're doing that marketing site, then this is kind of the pie chart that you should be matching against for all the components you use, right? Or you're doing this ERP, and here's the pie chart you should be using for that. I knew I was going to want that slide back. So there's a bunch of different things going on, at least loosely connected to Fedora, that are trying to deliver on some of these components. First and foremost, actually not really foremost. First is RollKit, which is, like I was kind of saying with Fedora Server, this is an idea of being able to install a module or install a thing in such a way that you can kind of guide the user into its installation, or feed it somebody else's guide to that installation in kind of a generic, simple way, right? So instead of going through all the different machinations of kind of setting up a DNS server or setting up a database server or whatever, to essentially wrap that command infrastructure into one place so that you can deliver it to users, and then the users can actually deploy it in a simpler way. XTG app is a containerization tech that is kind of mostly coming out of the GNOME space, but the idea here is that this is kind of the bag, right? Or one of the bag options is a way to deliver a application, generally speaking in this case, desktop applications, to an end user in a way that is not only secure so that it actually can't bridge out, right? This kind of goes back to like, one of the things actually I probably should have mentioned earlier, but I'm going to say this now, is like, what we don't want to do is go back to what it was like in the late 90s, where the vendors could actually damage the systems I was running. So what we need to do is we need to be able to provide this kind of native packaging formats, applications easily shipped, and all these other things without actually removing control over the machine I'm running from the person who's operating it. So something like XTG app, what it does, right, is it says, okay, you can ship Firefox, and Firefox, you can do whatever you want inside your little self-contained sandbox. And every time you want to touch anything that is actually part of my machine, it goes through basically a security mount, right? So if any of you have Android phones, iPhone does this as well, but I have never used an iPhone, so I'm not terribly familiar with it. But at least on Android, right, it's that unfortunately, the way it's designed from a UX perspective is that screen you ignore when you install stuff. But the idea being is that there's a set of permissions to actually access your local hardware or your local system, really, and you have to grant it explicitly. And that's the only way the application can get to it. Same kind of idea here. Check it out, it's cool. Atomic Workstation is kind of the other half of that, is can we make the actual workstation itself basically invalid, right? So, or even idempotent in a sense, where it's, if you are familiar with Atomic at all, this is the idea is that you can't actually install anything on your desktop at all because you get this perfect, safe version of it, and then the only way that you can put applications on it is these kind of sandboxed applications. Another kind of related, and if you notice, a lot of these are all kind of related and all independent efforts that are starting to coalesce. But the next one is the Nulecule and Atomic App, and this is an idea where it's basically Nulecule is a specification, and Atomic App is kind of like a reference implementation of the specification. But the specification is a way to describe an application that is not only reusable. So going back to my Drupal example, is I could actually say, here's Drupal, right? It relies on a database and it relies on a web server. And then I can actually have other Nulecules that are web servers and database servers. And I can, as the Drupal Nulecule developer, I can say, you know what, your options are Postgres or MariaDB or whatever, these point to them, right? And then as the operator, I can say, you know what, I don't like that one. I'm actually going to go back to MySQL, so I'm going to just swap that out, right? And then Atomic App is basically will run those specifications. And this is very much based on kind of mostly Docker containerization. So Docker containerization with Kubernetes or with OpenShift. But the idea being that most of these applications will be multi-component, which is true for, I would say, most, 90% of applications these days. There's, I have in my notes, like I said, that I can't see, it's like we're not standing on the shoulder of giants anymore as application developers, right? We're standing on the shoulders of skyscrapers, right? And big, big skyscrapers. And as a result, we use huge chunks out of the rest of the open source world to be able to deliver our little sliver on top. And what Nulecule lets you do is kind of say, here's where to get those chunks from, right? And then deploy them in such a way that they can be orchestrated and operated in hopefully resilient ways. Still, unfortunately, relies on the developer. Kind of on another part of the story is kind of that streamlining the operating system and delivering metadata. This is definitely much more nascent. Relatively recently, we were able to get weak dependencies into RPM, right? And what that allows us to do is, kind of in that core area, right? We can not require everything all the time, right? We can say, you know what, I can have, my core functionality is this, and so therefore I require these dependencies. But I also have some optional functionality, for example, right? And so I can softly require those dependencies. If I don't have those, I just won't have those optional features, right? Or potentially, you can also do kind of more sophisticated kind of swapping of what is providing a dependency. And then the base working group and the environments and stacks working group are both working on, so the base working group is mostly working on trying to slim down that core or trying to simplify the base OS and actually define the operating system itself as a separate and distinct thing from all of these dependencies and everything else. And then environments and stacks is really working on getting native formats available to end users. Some of that is, there's definitely some ideas there. I would say it's still pretty young. And then a model for how do we ship metadata to those end users? How do we have independent metadata? How do we, and also how do we integrate it into the ecosystem, right? Because, going back to as a distribution person, right? As a person who, I'm in the Fedora Council, right? I have a vested interest in Fedora being a distribution and being something that people want to put applications on top of. I know we have to fit our tool chain into the developer ecosystem, right? So I can't tell every single Ruby developer out there to only use my special gems, right? So what I need to do is I need to be able to ship the metadata in a way that they can consume, and I need to be able to ship them or allow them to ship or allow them to get, or whatever the right word is, the dependencies they need. And they need to be able to choose the crazy stuff, right? They need to be able to choose this bleeding edge beta version of something. And I need to be able to let them choose that as well as see the metadata that says that they're crazy. Right? Go ahead. Oh, sorry, I thought somebody had a question. And this is basically kind of my wrap-up slide here. We'll be talking about this more at DevConf, which is a conference Red Hat puts on in Brno in the Czech Republic next week. And I will be presenting something like this talk. I highly encourage any application developers in the audience. Recently Fedora put up developer.fedoraproject.org to try to engage more application developers, right? I mean, like I said, I'm a pure application developer. I built, I like to say complicated websites, but websites for most of my career, right? The thought of actually doing anything kind of inside of the OS is not my bag, right? We need more people who come from my experience to participate in this conversation so that we can provide a distribution that is useful to developers, that is what they want it to be. And then as operating people, right, or as sysadmins or as packagers or whatever, we need to make it so that they can't hurt anybody else, basically. And then, like I said, we had this kind of falling down a little bit because the rings didn't work once you got past a certain point. So we really need your help. We need you guys to participate in the conversation. We need you guys to recognize that this is an interesting new model, and please come and help us. A deadline for myself, Flock is the Fedora user or developer conference, Fedora conference, and it's in August, and I promise to at least submit a talk, to deliver a talk about how much progress we've made in the next, like I said, this next phase by then. And that's pretty much all my slides. There's links in the references. I meant to put the slides up before the talk, but I forgot, and so I will put it up right after the talk. And then, a whole mess of attributions. One I'd like to call out is this template was done by somebody in the Fedora community, and I think it's awesome. I highly recommend it. Questions? I can repeat them too.
You were talking about not necessarily needing to have build dependencies, essentially, of things in ring 0 also be in ring 0. Doesn't that leave you with a risk that you end up shipping software that no longer builds, or that builds but the result is different or incompatible because the tool chain has moved on?
Right. Yeah. So the question was basically, for anybody who didn't hear it, is if you're not maintaining the quality of the build dependencies, for example, at the same level as its output, what's there to ensure that you can actually build it again, ever, right? So I would argue that, yes, that is definitely a problem. One solution that we've been proposing is essentially maintaining them as a kind of binaries, right, versus as shippable packages. So there's kind of a difference between being able to use those things to do a build and actually being able to use those things and also use them to build other things. Does that make sense? So yeah, ring 0, right? Here are its build dependencies. When Fedora 23 came out, this is the state they were in. We are going to maintain them to be able to continue to build Fedora 23 or the things that went into Fedora 23, but we don't promise that you can build anything else.
Right. That makes sense, yeah.
Right. Any other questions? No. Apparently I'm out of time, so if you have other questions, I am here and I'll be around all day, or I will see you at the next thing, or you can find me on the interwebs. Thanks for coming.